When an object is in equilibrium, the sum of all forces acting on it equals zero, and the sum of all moments equals zero. This means every push and pull cancels out perfectly. The two conditions are the net force equals zero and the net moment equals zero. Now let's see this in real life. A bridge must be in perfect equilibrium to stay standing. The weight of the deck and traffic pushes down, while the piers and cables push up with equal force. Engineers apply the sum of forces equals zero, and the sum of moments equals zero, to design every joint and support so nothing rotates or collapses. A coplanar force system is a set of forces that all lie in the same flat plane. Each force has a magnitude and a direction described by its angle. We resolve every force into a horizontal component, Fx equals F cosine theta, and a vertical component, Fy equals F sine theta. The resultant is found by summing all components. Rx equals the sum of Fx and Ry equals the sum of Fy, giving a single resultant force R. Now let's see this in real life. Engineers use coplanar force systems to design bridge trusses. The bridge deck carries a vertical load from traffic weight. Wind adds a horizontal push. Each truss member carries a force along its own angle. By resolving every member force into components and summing them, engineers check that the resultant at every joint is zero, meaning the bridge stays in perfect equilibrium and nothing moves. A three-dimensional spatial force system is a collection of forces acting on a body in all three directions, x, y, and z. Each force is resolved into three components. The resultant force is found by summing all x components, all y components, and all z components separately. The magnitude of the resultant equals the square root of Rx squared plus y squared plus Rz squared. Now let's see this in real life. In structural engineering, a crane hook experiences forces pulling in all three directions simultaneously. The cable tension pulls upward, the load pulls downward, and wind pushes sideways. Engineers resolve each force into x, y, and z components, sum them up, and compute the resultant to ensure the hook and cable can bear the total load safely.